energetic students, my dear physics enthusiasts. I don't know whether you're preparing for an NSEP exam, some of you are preparing for JEE exam, NEET exam, or some of you are actually not even preparing for any particular exam. You're just physics enthusiasts, and that's what brings you here to this session. So, whatever the reason for coming to this session, I guarantee that you're going to go with a smile on your face because you're going to learn something very amazing today. And that something amazing is the flip of a coin. Now, I know everybody knows. I mean, since your childhood, you've been flipping coins, whether you play cricket, hockey, kabaddi, or maybe just for fun, you've been flipping coins. And we have been told that mathematically, for an unbiased coin, the probability of falling heads or tails is 50-50. Obviously, unless it's a coin like in that movie Sholay, where both sides was heads. So if one side is head, one side is tail, and it is even distribution of mass out there, we know when we flip it, we don't know. It's a 50-50 chance that it's going to be heads or a tails. So my question is, can you really predict it? Maybe there is a way out there. I don't know. We are just going to discuss that. So is it really random or is it predictable? So we are going to talk about the chaos theory, and chaos theory is amazing, something new, something mind blowing for you. Maybe some of you have already studied. For some of you, it's going to be new. So chaos theory is going to tell us whether it is really random or is it predictable. Now, before I start, I'm going to give you a brief introduction about myself. And usually, I don't talk much about myself. I talk more about physics. But a very quick introduction. My name is Bhavdeep Sethi. I've done masters from IIT Bombay, and my passion is to convert physics haters to physics lovers. And I always say that nature is the best textbook out there for physics. You go out in nature, you explore nature, you play with nature, not in a bad way, like messing up with nature. You enjoy the nature, and that's where you actually learn physics. With due respect to all the amazing books out there, I'm not saying the books are not required. Books are amazing, but I'm saying the best textbook out there is nature. Now, coming back to the main agenda, but before that, a big warning here. There is not going to be any spoon feeding. All my sessions are very conceptual. So, if you're expecting any ready-made formula being given here and telling you that in exam you do this formula, use this formula, that formula, no, that's not going to happen. It's all conceptual class, no memorization. Now, coming back to the main point here, there are two things to understand. First is Newtonian physics, and one is the chaos theory. I will explain you what that means. So let's take the example here or the situation here. Is the flip truly random? So forget what is Newtonian physics, forget what is chaos theory. My simple question to you is, if you take a fair coin and if you flip it, if you toss it, is it really random? As in, when you flip it, is it random that it's going to fall heads or tails? As if you don't know. So let me know in the chat box, in the comment box, yes or a no. Do you think it is random? As in, when you flip it, you don't know. I mean, it's going to fall heads or tails. It's all random with a 50-50 chance. Do you think it is random or is it predictable? So let's analyze that. Taking a very simple thingy. See, what is Newtonian physics? Newtonian physics is all about the laws of nature explained in laws of motion, the three laws of motion, then gravitational law, and then the equations of motion. That's all classical physics, Newtonian physics. So thinking about Newtonian physics, let's say I'm not talking about tossing the coin. Let's say it's a ball, maybe this pen. So if I throw this pen up, it goes up, it comes down. No, don't you think it's very predictable right now? Because if you take this object, pen or a ball, and you throw it up with some velocity, let's say u, and this is the ground here. So you say, okay, it goes up and then it comes down. So it comes down and you take this displacement, maybe negative displacement there, positive initial velocity. And you can say, yeah, I can use S equals ut plus half at squared. So you can basically predict exactly as in how long will it take for the ball to return to the ground. It's all predictable, it's all calculatable, if that's the right word. You can plug in the initial velocity, you can plug in this negative displacement, acceleration is negative acceleration due to gravity, and you can solve that quadratic equation. And you know that is the amount of time it is going to take to for the ball to fall down. It is predictable, it is not random as if you throw it up. It may take 9 seconds, it may take 10 seconds. Obviously we are ignoring the air resistance and other forces here, viscous forces, but it's all predictable, isn't it? Now let's take another example. Let's say there is a disk here. I don't know, let me draw a disk here, and then I draw this axis as in maybe this is the disk, or I'll take a bigger disk here. This is going to help me. So let's say this is a ring, and this is my axis of rotation, and I rotate it. So maybe there is an axis here, and I rotate it. Then I know I'm giving some angular velocity omega, initial angular velocity, and because of some frictional forces out there, there might be retardation. And then I know it's moving with omega naught, initial omega, and given a time I can find how many rotations it would do, or how many radians it would have traveled. So I can use the similar equation in rotational motion and say theta equals omega naught t plus half alpha t square, where alpha is the angular acceleration, angular retardation, whatever the case is. So it is all predictable. Again, I mean, if I look at that rotation here, it is all predictable. It's all Newtonian physics. But now think about it, when you're flipping a coin, isn't it a combination of these two? The coin is moving up, the coin is coming down. It's simply this. And during that journey, during that time, it is rotating. So if I know exactly how much omega naught was, as in when I flip the coin, if I see, we are not talking about whether we are able to measure it or not. It's so quick, and all that is happening so quick. Let's take a situation where you're able to know the angular velocity there. So you know with that angular velocity it is going up. So let me take the bigger one here. So if this is flipping, you know it's going up, going up, going up, and then rotating, rotating, and you know exactly how long it will come, how long it will take to come down. So if you know that time, you can plug that time here, and you know actually how much angle that is. And can't you actually predict that if this was heads on the top, is it going to fall heads or tails? Honestly, think about it. Seriously, I'm really serious here. Think about it. Isn't the flip of a coin really a predictable event here? Because let me repeat what I'm saying. I'm saying, let's say you start at this height, and this starts to rotate as well as move up. Now think of it as an object which is going up, traveling up, and then returning back. You know what was the height with which it was thrown with, and then it goes up and then it comes down. So you can actually calculate using S equals ut plus half at square. You can find the time it takes for the coin to fall on the ground. Now, during that same journey, during that same time, it was also rotating. Now, let's say you have the information of that omega, initial omega, and let's say you have the information of air resistance, and let's say you know the angular retardation out there. You can plug in that time there, and you can find the radians it has traveled, and that will tell you whether it has completed how many rotations out there. And wouldn't you be able to tell exactly whether it is heads or tails? Now think about it seriously. It doesn't it look at the first glance, yeah, it is going to be a predictable behavior, but it is not a predictable behavior because of the chaos theory. So what we are talking right now is Newtonian physics versus chaos theory. All this looks good in the world of Newtonian physics, but when you factor in the chaos theory, everything looks like unpredictable. So first let's understand what is chaos theory. Maybe some of you know that what that is, maybe it's new, but I'll start from the beginning. So what exactly is this chaos theory? Now, written in simple words, it reads like this: a butterfly flapping its wings in Brazil could cause a tornado in Texas. Now, see, this is a big problem. Like, we read all these statements and they don't sometimes relate to our day-to-day life. I don't know where Brazil is. I don't know where Texas is. I live in India. So let's translate that to something local here. So a butterfly flapping its wings in Kerala could cause a storm in Delhi. First of all, there's no tornado in areas like Delhi, so I use the word storm. So what this means is, let's say there's a butterfly out there in Kerala and it's flapping its wings. The flapping of the wings actually initiates the movement of the air, and that movement of air grows exponentially and causes a storm in Delhi. It might look funny to you, right? Or it might look funny to you, and that's exactly what that chaos theory is. Chaos theory is saying a little input here, as in a little input there, would cause a big output there. That is what a chaos theory is in simple words. I'm going to explain you with an example, but chaos theory basically translated into simple words is as simple as saying a butterfly flapping wings in Kerala would cause storm in Delhi. It's actually called the butterfly effect. So let's take a quick example here from your daily life. So very, very simple example. So let's say you wake up in the morning every day, you get dressed up, you have your breakfast, you say bye to your family, and you go to school. Every day, that's your routine, let's say. Now let's say one fine morning something different happens. Let's say you get dressed up, everything is on time, you step out of your house, you're ready to go to school. Immediately you remember, oh my God, I forgot my favorite pen in the house. So you turn back, you take a U-turn, and then you go to the house, you go to your study desk, you pick the pen, and you come out. And let's say it takes as little as 10 seconds to do that. I'm really making the situation very simple. So you remembered that you forgot the pen, and you go to the house. Inside the house, you grab the pen and you return back. Let's say it takes only 10 seconds. It's just a matter of 10 seconds, not a big deal. Now you start for your school. I don't know what vehicle you take. Maybe you go in a school bus or whatever. Your father drives you, or mother drives you somewhere. Let's say your father, mother, somebody drives you to school. They give a ride to the school. Now, as soon as you reach a traffic signal, the traffic signal turns red. Now think about it. Had you started without picking up the pen, you would have saved those 10 seconds, and the traffic light turned red just now. Wouldn't you have crossed the traffic signal before it turned red had you not taken the U-turn? And I'm assuming here your parents are very, very good citizens, and they're not going to break the laws. They're not going to jump that red light. Obviously, I'm saying your parents will stop at the red light, right? But had you not taken the U-turn, you would have crossed it while it was green. Yes. And let's say it's a long red light. It takes roughly, let's say, 90 seconds to turn green again. So those 10 seconds that you took to take that pen, it has now turned out to be a delay of 90 seconds. Right? So that delay of 10 seconds has grown to 90 seconds because now you have to stop and then 90 seconds. Fair, fair. 90 seconds is not a big deal. Now you start driving. Unfortunately, right in front of in front of your eyes, so as you start driving, you cross that green light when it turned green. Now let's say on the road, immediately after that, maybe 2 minutes later, you see an accident happening. Unfortunately, I don't want it to happen, but let's say it happened, and that means the road was closed because there was an accident that happened, and very bad accident, so the entire road was closed. And the police came in, the ambulance came in, people helped out there, and the road was open in 15 minutes, let's say. Now think about it, that those 10 seconds caused a delay of 90 seconds at the traffic signal. But again, it caused another 15 minutes delay, because think about it, if had you not taken that U-turn and not delayed by 90 seconds there, you would have crossed before that accident happened. So now because of that tiny little delay of 10 seconds, now you're late by 15 minutes. Right? See how where we are going now. Not still not a big deal. I mean, it's just 15 minutes, and let's hope everybody was safe in that accident, so no harm, damage done to the bodies and people. So let's hope that that's the main thing. 90 minutes or 15 minutes, I mean, doesn't, yeah. So now basically now you are late by 15 minutes, so you reach your school. Now what happened during those 15-minute delay? So when you reach the school assembly is over, because assembly was 10 to 15 minutes long. So you missed your assembly. Now let's take a situation that during that school assembly, your principal asked a random good science question, let's say physics question. So it was an open challenge to all the students in the assembly. Here is a physics question on the spot, and whoever answers it gets an opportunity to represent the school at some inter-school competition, science or competition or physics competition. Now, obviously, you are a Vedantu student. You study with Bhavdeep sir, so you are very smart and you know physics conceptually. You would have easily answered it, but because of that delay of 15 minutes, you didn't get an opportunity to participate. So somebody else answered it, and that person, that student, got an opportunity to participate in that inter-school competition. And that inter-school competition actually was a part of the series of competitions which would lead to statewide and then nationwide. And the winner of the national competition would have received a chance to visit ISRO maybe. So see how the things are moving here. The delay of 10 seconds there caused a delay of 90 seconds at the traffic signal, caused a 15-minute delay at the that accident spot, and that caused you to miss that opportunity to represent the school. That caused a missed opportunity to visit ISRO. Just 10 seconds of delay, and this is exactly what the chaos theory is. The tiny little change in the input, as in your starting from your house, resulted in a big difference in the output. Had you not delayed yourself to pick that pen by 10 seconds, everything would have gone very smoothly and you would have reached on time for the assembly. You would have answered that question in the quiz competition, and maybe you got an opportunity to represent school, then state, and then yeah, you would have won that competition at the national level, because I am confident about you. But all this did not happen because of that 10-second delay. So this is an example of that chaos theory. Newtonian physics says things are so predictable that 1% change in the output may result in 1% change or 2% change. But look at the amount of change we are talking about here. And this is exactly what is chaos theory. So now, if you find that funny that a butterfly flapping the wings at in Kerala could cause a storm in Delhi, it could actually happen if you have such sequence of events. And that is the chaos theory. So you see, small changes in the initial conditions can result in huge differences in output over time in chaotic systems. These are chaotic systems. And actually, as a matter of fact, most of the systems are chaotic. We don't observe it because we are looking at the macroscopic level. If you look at the air molecules moving here, it's all chaotic. So we can see some examples from our daily life. So very simple example, and you will be amazed that you never realized this. So these examples are something in your day-to-day life, and you will see how chaotic they are. Dropping a paper. Think about it. When you drop a paper, so see, dropping a paper, isn't that S equals ut plus half at square, Newtonian physics? But when we are doing S equals to ut plus half at square, we are ignoring the fact of air resistance. And it doesn't really matter. Look at this, it doesn't really matter in the case of this pen. But when you talk about paper, in the case of paper, that air resistance is huge and it matters. So you can say, so what? So what? Because now you have mg going down, the viscous force going up, the buoyancy going up. You can calculate the net acceleration and you can find S equals ut plus half at square. But think again, when you drop the paper, it doesn't land straight downwards. It goes somewhere here and there. Look at a tiny paper. It goes all the way. I don't know whether it lands there. Why is it so? Because the air is moving, and that movement of air is going to cause that movement in the horizontal direction also. And tiny little interaction between the air particles and paper is going to cause a huge difference in the position where it lands. So if you drop the paper, it lands at spot A, When you drop it again, it lands at spot B, C, D, E. It's all chaotic. It is unpredictable. And why is it unpredictable? Because there is a slight change in the input. Basically, the input may be as simple as, are you dropping from this position or a micrometer above it? That tiny little difference in the height itself makes a difference. The tiny little difference in the molecule, one molecule striking with this speed here or this speed here, is going to exponentially change the position where it drops. Try it out, and that is the reason it's all chaotic. Similarly, bubbles in boiling water. Let's say you take a pan of water, you put it on a flame, the first bubble comes here or there or there. You cannot predict why. I mean, it might look very simple example here, but think about it. You have the surface of water. You can never predict where the bubble is going to be. Why is it so? Because the surface of the pan looks smooth, it is not smooth. There is a roughness out there, it is not as smooth, and depending on the texture of the surface, depending on the little unevenness there, the bubble might rise here or rise here. It is all chaotic. The reason for that is tiny little difference in those input variables is going to cause a huge difference in the output there. Bouncing of a table tennis ball. You take a table tennis ball, drop it, it's going to bounce, and it is not going to bounce this way. It is going to bounce sideways, obviously, and you don't know it's going to fall this way, this way, this way. And let's say it goes vertical only. Even when you're talking about vertical, let's say you count. Let's make it simple. You drop a ping pong ball or a table tennis ball, you drop it, it goes down, it bounces up, and then does stop bouncing, bouncing, bouncing. Maybe it stops after 10 bounces, maybe 11, maybe 12. It is all chaotic because the little difference in the height makes a huge difference. Similarly, the path of a smoke from the candle, all these are chaotic examples. Now let's come back to the main agenda of flipping of a coin. Now, flipping of the coin, similar, see, we saw the flipping of a coin is basically a combination of it moving up and down, saying S equals ut plus half at square, along with omega theta is equal to omega naught t plus half alpha t square. But wait a second. There is so much happening there. What does it depend on? It depends on the initial force. See, first of all, when we are talking about that omega naught depends on how much force were you applying with your thumb here. Let's say you have a tossing machine. You can say, okay, the force is constant, but even a millionth of a Newton there is going to make a huge difference because it is a chaotic system. The very tiny difference in the input out there is going to make the change in big change in the output. Then it depends on the angle of flip. When you're flipping it, you don't know. I mean, a very tiny, a micro radian would cause a big difference. Distribution of mass. I mean, it looks like a very smooth coin, but honestly, at the microscopic level, there are differences. It's not, the center of mass is not going to be at the exact center out there. The moment of inertia is not predictable here. Air resistance. Now you might say, okay, the air is very calm here, but at the microscopic level, all those Brownian motions are going on. So very tiny collision of an air molecule here is going to make a big difference. So whether when you flip it for the first time at this height, the molecule colliding was in this direction, that is a huge difference that it is going to make. Now it is mind blowing, don't you think so? That one molecule striking that coin at some known or unknown angle is going to cause a big difference in whether it is going to be heads or tails. Height of tossing, you might say, okay, I'm going to toss it exactly like this, but this tiny little changes because it's a chaotic system. Surface it lands on. Now it might look like a very hard surface, but it has some kind of elasticity out there. And again, it depends on the surface is smooth, and let's say I'm taking it on my palm. Again, it all depends on all these parameters and many more. So with these many parameters going in as inputs, going to whatever precision you go for, you're going to have a slight uncertainty out there in the measurements, and those little tiny uncertainties are going to magnify. Another example, very beautiful example here, is going to be weather prediction. We have all seen, okay, they predict, okay, 10 days later it's going to be sunny and it is cloudy, it is storm maybe on that day. And sometimes you feel, I mean, why? Because as science has been so advanced now, why can't we just predict the weather? We cannot predict the weather because the weather prediction is very chaotic. It's not like we lack the informations. We know the informations. But what is the weather going to be 10 days down from now? It depends on so many factors. It depends on the temperature right now in your location. It depends on temperature in the neighboring cities, in the neighboring states. It depends on the air pressures out there. And again, whatever measurements you do, there is going to be little uncertainty in the measurements, and that little uncertainty, whether it is 23.2 degrees or 23.2000005 degrees, this is a big difference. It depends on humidity, it depends on the wind flowing in the neighboring areas, then cloud cover, then the weather fronts, the cold and the hot air meeting, then geography and topology of the local area, and not just the local area, also the surroundings. With so many inputs going there and tiny little uncertainty in these, it's going to be magnifying the output. And that is why when you say it is going to be sunny, it may not be sunny because it is a chaotic system. Also, historical data and trends, obviously, right? So you see how the weather prediction, the flip of a coin, all these are, I would say, deterministic if you're able to. So let me put it in this way. Had you been able to exactly know omega naught, had you known exactly the moment of inertia, had you known exactly what all air molecules are moving at that point of time in all these locations, and had you known exactly how much is the height to the 1 millionth of a meter precision, had you known with those many precision, yes, you can predict whether it is heads or tails. But because there will be always uncertainty in our measurements, and that is why it is unpredictable, because tiny little uncertainties in those measurements are going to cause a big change. So basically, when you talk about Newtonian versus chaos theory, Newtonian laws explain very beautifully the laws of motion, and it's not like they're wrong, they are working fine for macro world out there. If you take a ball and you toss it, or not toss it, just throw it up, and you can predict, obviously, unless you're talking about the quantum world out there. We are talking about the day-to-day world here. Newtonian physics is very beautiful and it predicts everything. On the other hand, chaos theory shows that small changes can lead to big differences in certain situations where they magnify exponentially. So both of them are going to work together. This shows why some things like a falling of a ball are predictable, why on the other hand the coin toss is not predictable. The world follows rules, but it can still be unpredictable. Isn't that a very beautiful statement? And that's why I love physics, I love nature. See, sometimes it looks like more you go in depth into science, the more away you're going from the nature. It's the other way around. If you study physics in depth, you actually come more closer to nature and you try to appreciate it more. So if you really loved this session and gained some common sense insights into physics, please share this video with your friends so that they also enjoy this. Now, if you really want to enjoy physics to another level, you can join our course that we are starting, a paid course, which is for NSEP 2025. So it's going to start on, well, it's not written here, but 10th of February is when the first session is. And the classes are going to be on, I don't know, I should have put this here. It's on Monday and Wednesday, 6 to 7 p.m. So we are starting a paid course. It's module wise. There are 5 modules there. And the classes are going to be every Monday and Wednesday, 6 to 7 p.m. The price of each module is 4,000 rupees. So 5 modules are 20,000 rupees. But actually there's a big discount going on there. So by the way, it's for students who want to learn physics conceptually. It is not for you if you just want to memorize expressions, first of all. So how do you join this? So you can either click on the link at the bottom, or you can go to vedantu.com. So there's a link here which gives you the coupon also, but you can go to vedantu.com, go to courses. I'm clicking on courses. Once you click on courses, you see Olympiad here. You click on Olympiad, and here you will see NSEP 2025 full course. So you click on that, and here you will see there is a discount here. So instead of 20,000 rupees, you pay you get 39% discount. So you pay only 12,150 rupees. Now you have given you my Telegram ID also, so you can connect with me anytime. If you face any challenges in joining, you can basically connect with me. Here's my Telegram ID, Bhavdeep Singh Sethi. So you can join me, you can connect with me, and I am going to guide you on that. So this is, and these are the modules, by the way. So all this is 11th portion, and this is all 12th portion. We're going to cover everything in physics of 11th and 12th. So that will cover your NSEP exam, JEE exam, NEET exam, and your passion for physics. And that's that. I'm going to end this session now, but I hope that you will be connected here. Share this video, subscribe to this channel, and keep up the high Josh. So see you. Bye bye.